it says, a girl stands on a platform in a classroom. Okay, she throws a ball vertically downwards, so she throws it down, okay, to the floor, hoping that the ball, after it bounces on the floor, will hit the ceiling of the classroom. She throws the ball with a speed of 8, so the initial velocity is 8 meters per second, and it's downwards. Okay, and it's from a height of 1.8 meters. It says ignore the effects of air friction. Write down the magnitude and the direction of the acceleration of the ball immediately after the ball left her hand. Well, what is the only force that's acting on this ball, other than air friction, which we're ignoring, after the ball has left her hand? Well, the only force acting on it is gravity. So the magnitude and the direction of the ball acceleration is going to be 9,8 meters per second squared downwards. In grade 12s, again, you may not just draw the arrow, you need to write the word downwards. Now it says, is the motion of the ball while it is moving downwards to the floor, towards the floor, free fall? Explain your answer. And the answer is yes, because once it has left your hand and there's no other forces acting on it, then it is, other than the force of gravity, then it is in free fall. So that we've done, and that we've done. Now it says calculate the magnitude of the velocity with which the ball hits the ground. Okay, so we've got an initial velocity of 8. We are choosing down as positive. Your acceleration is 9,8. Your final velocity is the question mark, and we've got delta x is 1,8. So if you go through your equations of motion, you'll see the best one to use is vf squared equals vi squared plus 2a delta x. That is 8 squared plus 2 times 9,8 times 1,8. We're going to use our calculator. So we've got 64 plus bracket 2 times 9.8 times 1.8 close bracket equals, and then we're going to square root the answer, and it equals 9,96. So that's 9,96 meters per second, and it just asks for the magnitude, so you do not need to write downwards. Okay, now it says, how long does it take for the ball to hit the floor? Okay, so there are a couple of equations we can use, anyone with a time. So let me just show you something. You've got VF equals VI plus A delta T. We've got delta X is equal to VI delta T plus a half AT squared. And then we've got delta X is equal to VF plus VI over 2 delta T, and then obviously this one here. Now the problem with this one and this one is that we've worked out VF here. And if we've got VF wrong, then when we work out the time, we're also going to get it wrong. So I personally, even though it's a trickier of the equations, would use this one here. Simply because if I've made a mistake and got VF wrong, then I'm going to lose marks here. Okay, carryover marks only work if there's no other way to do this question. And you can do this question without using a calculation that you've already done. So that's why you wouldn't get carryover marks if you got this wrong. So delta x is equal to VI delta t plus a half A delta t squared. This is 1,8 is equal to the initial velocity, which is 8 times by t plus a half times 9,8 t squared. So therefore we've got 4,9 t squared plus 8t minus 1,8 equals 0. And yes, we do have to use the formula. So we've got t is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So we need to substitute in. So we've got minus 8 plus or minus the square root of 64 minus 4 times 4,9 times minus 1,8 all over 9,8. So then we put this in our calculator and we go minus 8, we've got plus, why don't we, square root of 64 minus bracket 4 times 4.9 times negative 1.8, close bracket, all over 9.8 equals 0.2. So the answer is 0.2 seconds. And I don't need to do the other one because the other one's going to be a negative and you can't get a negative time. So the correct answer is 0.2 seconds. So there you go. Now we've got that. So the time it took here was 0.2 seconds, and the final velocity here, where is it? It is 9.96. Now it says the ball bounces inelastically on the floor, where the speed of the ball decreases by 20%, and the ball is in contact with the floor 0.01 seconds. Determine by means of calculation whether the ball will reach the ceiling after it's bounced. Okay, so I'm going to erase this, and then we're going to use our information to calculate what the final height is. So we've also got Vf squared is equal to Vi squared plus 2a delta x. Okay, just to fill in those equations. Right, so they say determine by means of calculations whether the ball will reach the ceiling after it's bounced. In other words, we want to know what is its maximum height after it's bounced. So after it's bounced, we need to work out what its initial velocity is. Initial velocity is 20% of what is, decreases by 20%, which means it is 80% of what originally was. So therefore it's going to be 80 over 100 times by 9.96. And we just need to pop that in our calculator. So that is going to be 0.8 times 9.96. which is going to be 7.97. So that's 7.97 meters per second. I hope you understand that. That's what they're saying. They're saying the ball went twing, stayed there for a little while, and then went up. It hit the ground at 9.96 meters per second. Okay, this bit here we wouldn't actually see, but it's basically stationary for a little while. And then it bounced up. And when it bounced up, some of the energy had been absorbed during the collision. It decreased by 20%, which means it only had 80% of the original speed, which is now 7.97 meters per second. Okay, so now that is our VI. It's 7.97. We still have down as positive, which means that this is going to be negative. Our final velocity that we're aiming for is 0, because we want to find out what is the maximum height that this ball can reach when it's got a velocity of 7.97. The acceleration is going to be negative 9.8, because again we've chosen, actually it's going to be positive 9.8 because we've chosen down as positive. And we want delta x. That's what we're trying to find out. We're trying to find out what is the delta x. So let's see. I would again use this equation here. We've got Vf squared is equal to Vi squared plus 2a delta x. Vf is 0. Initial velocity is minus 7.97 all squared plus 2 times 9.8 delta x. Therefore, let's just use our calculators. Let's just square that. And we get 63.49. So 63.49, and that is going to be negative because I'm taking it across, divided by 19.6 is equal to delta x. So I'm going to divide this by 19.6, and you can see that that gives me 3.24. So it's negative 3.24 meters, and its negative is correct because we chose down as positive. So this means that this is upwards. So the maximum height that this ball can reach is, somewhere. It's 3.24 meters. So does it hit the ground? Nope, it doesn't, and this is why. Does it hit the ceiling? No, it doesn't. Right, so we want a velocity versus time graph, and we've chosen down as positive. So this is velocity in meters per second, and this is time in seconds. And remember, you always need to put a heading in velocity versus time. Okay, We start off with a velocity of 8, and when it hits the ground 0.2 seconds later, it is going at a velocity of 9,96. That's when it hits the ground, okay? And it hits the ground there at 0,2 seconds. But for 0.2 to 0.21, it does nothing. So at this point, 0.21, it has zero velocity. Then it bounces up with a negative velocity of 7.97 seconds. So there we got 7.97. Okay, that there, those are supposed to be dotted lines. I'm sorry, it's not very clear. That's 7,97. And then it travels up until it gets to a final velocity of 0, because at 3.24 meters it is going at 0. Okay, and this is going to be, what is that, 0,21, and that is 0,2. I'm sorry about the tool. And what's important, and very important, is that this line should be parallel to that line, because this gradient is the slope of the velocity versus time graph, which is your acceleration. And your acceleration is the acceleration due to gravity, which is 9.8. It's constant. So that slope there should be constant. Okay, and that there is how you do this velocity versus time graph. And please note what's important: the initial velocity of the ball, done. The velocity and time when the ball hits the floor. So there's the velocity and there's the time. The velocity and time when the ball leaves the floor, there's the velocity. There's the time, there's the velocity. Always make sure that you include everything that they've asked. Have a great day.